Trigonometry, Chapter 3, Radian Measure and the Unit Circle, Section 2, Applications of Radian Measure, Video 1, Arc Length Formula. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, 3.1, we learned about radian measure. In this section, 3.2, we learn about applications of radian measure. In this video, we discuss the arc length formula and view some examples. Recall the formula for radian measure. If the central angle theta in a circle of radius r intercepts an arc of length s, then the radian measure of theta is given by theta equals s over r, which is like asking how many radii fit inside this arc. But as with many formulas, we can solve for another variable and create a new formula. If we want a formula for arc length, we simply solve for s. That's pretty easy. Just multiply both sides by r and cancel the r under the fraction. We get r theta equals s, but since we're creating a formula for arc length, I would like it to say s equals. And so here's our formula. In an arc, if an arc in a circle of radius r is intercepted by a central angle with radian measure theta, then the length s of that arc is given by s equals r theta. So it's a multiplication problem. For example, find the length of an arc intercepted by a 45-degree central angle in a circle of radius 10 centimeters. Well, we were given the central angle measure and the radius, which we both need to calculate the arc length. There's a slight problem. Before you use the formula, you must make sure that the angle is in radians. If it is not, your answer will be wrong. So we need to convert 45 degrees to radians, but that's fairly standard. We simply multiply it by pi radians over 180 degrees to cancel the radians and to cancel the degrees and bring radians into the value. That will simplify to pi over 4 radians. And honestly, at some point, you'd need to just know that pi over 4 is 45 degrees and vice versa. Now use the arc length formula with theta equals pi over 4 and r equals 10 centimeters. It's a pretty straight shot. Here's the arc length formula. Here's the radius and angle inserted. If we just straight up multiply without simplifying, we'll get 10 pi over 4 centimeters. And of course, we can reduce this by 2 to get 5 pi over 2 centimeters. So the arc has length 5 pi over 2 centimeters, or about 7.85 centimeters. It's not uncommon in a question like this to ask you to round your answer to a certain precision. Because if you're going to measure something, saying 7.85 centimeters makes a lot more sense than saying 5 pi over 2. 5 pi over 2 is exact, but 7.85 is better in terms of measuring. Now you try. Pause the video and try the following. Find the length of an arc intercepted by an angle of 120 degrees in a radius of 24 inches, and find the radius of a circle if the central angle of measure 5 pi over 6 intercepts an arc of length 10 pi centimeters. So in this case, I gave you the arc length and the angle. You find the radius. Pause the video, give it a try. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, 1.